In this class, we're going to take a look at how you multiply surds together, and we'll also take a brief look at how you divide surds. I would say multiplication of surds is more important, so we're going to focus our attention on that. We'll take a look at the dividing part just at the end of today's class. So there's a few different scenarios that we've got to be able to deal with, and it's gaining enough experience of these different scenarios, which is probably the most difficult thing in this topic. The main result to kind of remember here is that if you take some surd, so let's say root A, and you multiply that to root B, so two surds multiplying together, then the answer you get is root AB. In other words, you take the two numbers, you multiply them together, and you put them under the root, and that goes both ways, because you could start with root AB, and you could split that up as root A times root B, so going in both directions. So that's really the fundamental kind of key technique in this topic, knowing how to work these like this, and we'll take that idea and we'll apply it to these different scenarios. So the first one here we've got directly in this kind of situation, so we've got a surd times a surd. Nothing really we can do there. These numbers are prime numbers, so they can't even be simplified. So root 3 times root 5 is just simply going to be root 3 times 5. You don't really need to write that line of work in, you can just go straight to multiplying them, so root 15. So nothing really much to do there, that's just for illustration, really. Next one's a little bit different. We could take the same approach. In fact, let's start by taking the same approach. So we've got these kind of in that sort of same format. Root 4 times root 4 is going to be root 4 times 4, which is 16. So that's fine, we've just done the same thing that we did up here. But the square root of 16 is a number we can actually take. It's got a square root and it comes out to be 4, okay? So that's one version of how to do that. So let's call that version 1, I guess. Version 2 would be where we just simply take the square roots of these numbers, because they do have square roots. Square root of 4 is 2, so we could simplify that to just 2 times 2, which also gives us 4. Doesn't matter which method you use, obviously you should get the same answer either way. And a third way you could do this one, just to show you the variety in these questions, root 4 times root 4, well, that and that are the same, so effectively we're squaring root 4. If you times something to itself, then you're squaring it, right? So that's actually just saying root 4 squared. But a square root and a squared cancel, and that's one of the key takeaways from this topic, thinking about a square root and a squared being the opposite of each other, so they cancel, so that just leaves you with 4 as well. So it's good to know those kind of different methods. They might not always apply, so for example, if that had been, say, a root 5 times a root 5, well, we couldn't use, for example, method 2 there, because you can't take the square root of 5. We would simply say that that is going to be root 25, which equals 5, or we could say that's going to be root 5 squared, and the square root and the squared cancel, and we get 5. However, in general, you should just know that the square root of a times the square root of a for any numbers, a just give you a, because you could either think of it like this or think of it like this. That's a good result to know. So if you see root 7 times root 7, the answer is going to be 7. Root 20 times root 20, the answer is going to be 20, etc. Okay, let me just get rid of this as well. Alright, so those first two examples are fairly kind of entry level. We're just going to try and build it up a little from there. So slightly more difficult scenario here, because we've got numbers in front of the surds. All that we do in this case is basically to treat the numbers, the whole numbers and the roots differently, separately. So we do 2 times 3 to give us 6, and we're going to multiply that to the result of this times this. So root 5 times root 5, we've just figured out is just 5, okay? So root 5 squared, which is 5. So we're just kind of using an extra line of working, and that comes out to be 30, okay? Slightly more difficult example again. This one, we could just multiply these numbers together, 27 times 32, but this is likely to be a non-calculator question, so personally I don't fancy doing 27 times 32. So let's see if we can simplify that calculation just by breaking these down, simplifying the form, and then multiplying them together. So We can do this by simplifying the surge individually. So root 27 we can rewrite as root 9 times root 3, and we're going to multiply that to root 32, which we can break down as root 8 and root 4. So if you're not familiar with what I did there, all I did was to take the numbers, think of two divisors that make 27, and then just break it down into two surds. Same with 32, I can make that by 4 times 8, so I can write it as root 4 times root 8. In fact, let me spin that around and make it root 4 root 8, because when you're doing this, you're looking for ideally a square number and a prime number, or at least definitely a square number and some number. So square number, prime number, square number, non-prime number, but at least we've got a square number, and that's so that we can then take the square root from the square number. So the square root of 9 is 3, so that number simplifies as 3 root 3. Second one's going to require a bit more work in. The square root of 4 is 2, so that's 2 root 8. We can simplify root 8 though as root 4 root 2, so root 4 root 2, which just becomes 2 root 2 because the square root of 4 is 2. So this number here, just the root 8, is 2 root 2. We're multiplying that by 2, so it's going to become 4 root 2. So a bit of simplification required there, so we get 3 root 3 times eventually 4 root 2. So now we've got this in a simpler format than multiplying these big numbers. It's more like this format here. So we could just go ahead and multiply the whole numbers together to give us a 12. Multiply the surge together. They're not going to cancel like they did up here to make a 5, that's fine, but at least we can compact them into one number, which is going to be root 6 in this case, and we just get a final answer of 12 root 6. So just a bit of a variety here in the question types. So we'll maybe just check out one final example in which we'll do a division. So let's say we wanted to take something like root 30, well, let's go with root 32, that seems like quite a good number, divided by root 8. So a couple of ways you could go about this. You could start to break them down. Let's actually maybe do it like that. So we just established that root 32 can be written in this form there, which we then simplified to this guy and eventually to that guy. So that can be simplified all the way down to 4 root 2. Root 8, we figured out as part of the process for that, came down to be 2 root 2. A root 2 and a root 2 cancel, so that guy and that guy would cancel. You're left with just 4 divided by 2, which is just 2, obviously. That's one way to do it, so we'll call that method 1. You might need to do that in certain scenarios. Method 2 though would just be to divide the numbers, so 32 divided by 8 is 4. Keep that under a square root though, so it becomes, well actually let me just put in an extra line of work in there. Let me just rewrite this whole thing. So I'm going to write that as root 32 over root 8, so just our starting point. But one thing you can do is to take the square root and put it over everything. So you can basically rewrite it in that form. That's one of the key takeaways for working with dividing by surds, rewriting it in that form. So you can either go from there to there or from there to there. Rewriting root 32 over 8 as just 4. 32 divided by 8 is 4, and we get root 4, and then just taking the square root of 4 to get 2. So we get the same final answer either way. Depends really on the numbers as to whether you would go for method 1 or method 2. But if they're quite friendly, round numbers like these ones were, either method is fairly easy to work, and it's a similar level of working. Just try and get enough experience with using the different methods and the different question types to know which method is going to be more efficient. So not trivial, these techniques. They require a bit of practice and probably more than anything a bit of experience. So definitely work quite a few practice questions on this topic and try to challenge yourself by working the ones that look a little uglier, the ones that you're not really inclined to wanting to work. That'll give you the experience of the more extreme versions, which just means that you won't be thrown off by them when you see them on a test or on an exam. So make sure that makes sense to you, and then try out a few practice questions.